Example number 2. These two octagonal garden plots are similar. So when we say octagonal, that means 8-sided. And we know that they're similar. So in the other situation, we had to literally take all the sides and compare them. Whereas this one, we know that they're similar. So we know that if we take a corresponding side, like AB and IJ, because of the way that their ratio is, we know that we can get a scale factor. So we need to use this information to calculate the length of GH and calculate the length of NP. So our scale factor is going to be 5.4 over 8.1 or 8.1 over 5.4. This is what we're going to use to multiply, depending on if we're going from small to big or from big to small. So this right here is less than 1. So we know that this is producing a reduction. So if we're going from big to small, this is the one that we will use. If this one right here, this is greater than 1, so we have an enlargement. That means that if we're going from small to big, we would use this one. So this one right here, calculate the length of GP. Now first, GH. So first we're going from small. Actually, the corresponding side here is going to be QP. So we're given large, and we're being asked for the smaller. So since we are being given the large corresponding side here, which is 32.4 meters, and we want to calculate the small, we're going for a reduction. So what we're going to do is we are going to say dimension, or just to be consistent with the last video, scale factor, times the reduction, times the dimension. So in this, since we're going from large to small or from big to small, we're going to say 5.4 over 8.1. So we're using that helpful ratio from the similar side that was given. And we multiply it by the dimension. So 32.4 meters. So what we would find is when we punch this into the calculator, 5.4 divided by 8.1. And then we hit the equal sign and we multiply everything by 32.4 meters. We're going to say that GH, so GH, let's just label this from the beginning, GH equals, it's going to be 21.6 meters. So we are using the fact that it is a similar triangle, and we have created a ratio because we know that AB and IJ are similar, and just as GH and PQ are similar, we use that information to calculate what the smaller one is. What about with B? Now we're looking at NP, so we're looking at this. So when I would, first things first, I would highlight what the corresponding side would be. And I would notice that we're going from the smaller picture, we're given the side on the smaller picture, and we want to find out what that length on the larger picture would be. So we are given small, and we're being asked for large. So that means that it's going to be an enlargement. So that means that the scale factor has to be bigger than 1. 8 over 1 divided by 5 over 4. 8 over 1 is greater than 5 over 4, so we know it's greater than 1. And this is what we use when we go from small to big. So our NP So remember that we're going to use scale factor times dimension. And if I'm just going to get a little bit more abstract here, we're going to say that NP equals 8.1 over 5.4 times FG. But we know what the length of FG is. It's 27 meters. So that NP equals 8.1 over 5.4 times 27. So we know that NP equals 40.5 meters long. So in summary, scale factors are most useful when they are considered as ratios. Similar polygons have corresponding angles. And corresponding size. With the same scale factor. So your 7.3 practice is a worksheet, so come on up and get it.